All right, we're going to go through another example on Hess's law. So we're going to determine the enthalpy of this reaction. So this is our final reaction. So that's our final goal. Okay, so we have to match all the pieces. So these are the pieces of our puzzle, and we're trying to get to this last step. So we can figure out what the overall enthalpy is. So these are the parts that the reaction is going to actually go through in order to make C2H6. So it doesn't just take C2H4 plus H2 to make that. It has to go through multiple steps in order for this to produce that product. So remember, the first step that we want to do is we want to go through and find the piece of the puzzle that has to be a certain way. So a piece that is only found in one of the reaction steps. So if we look through, the first one that I notice is hydrogen. So if I look at H, we know that H is here, and that's the only reaction that has hydrogen. So I'm going to look at the final step right here, and I see that, okay, H has to be a reactant as well. So we're good. So it's a reactant here, and it's a reactant here, so we know that it's on the correct side. But there is still an issue with it. So if we look on the final step, we only want a coefficient of 1. But in our reaction step, you'll see that there is a coefficient of 2. So we need to get rid of that 2. Okay, I can't just change this to 1. Okay, whatever I do to the reaction, I have to do to the overall enthalpy of this reaction step. So we want to turn this to 1. So in order to turn this to 1, I need to multiply it by 1/2. Okay, whatever I do to this one, I have to do to the oxygen and the water. So I'm just going to multiply the entire reaction by 1/2. Okay, I'm going to rewrite it just to keep organized. So I know that that's going to give us H2 plus 1/2 O2, and it's going to give us 1 H2O. Okay, now again, whatever I do to the reaction, I have to do to the enthalpy, because that's what's going to happen to the enthalpy. We're taking the amount away that we have, and remember, enthalpy depends on the amount, so I'm having the amount, so I'm going to have the enthalpy. So I'm going to divide this by 2. Okay, and when I divide that by 2, I'm going to get still negative, but 286 kilojoules. Okay, so now I'm going to look at reaction. I'm going to look at the next step. Okay, so we said that hydrogen was the only one in that reaction. But now let's see this one. Okay, so here if we look at this reaction B, this is the only reaction that contains C2H4. None of the other ones contain C2H4. So we know that it has to be a determining factor. So if we look here, okay, in the reaction that we're given, it is a reactant. Okay, let's look at our final step. All right, it is also still a reactant. So we right now know that it is on the correct steps. So we don't want to flip it. So we know that it's still going to be an exothermic reaction, still going to be negative. Okay, we want to check the coefficients. Okay, this has a coefficient of 1. This has a coefficient of 1. So we don't actually have to do anything to this reaction. So this one's all good. So we are done with reaction B. Okay, so as of now, what we've checked is all good. So now let's look at the last piece, the C2H6. The C2H6 is only found in this reaction. There's a couple issues with this. Okay, so the first issue that we can see is this side, it's a reactant. It's on that left side of the arrow, but in our final step, we want it to be a product. Okay, which means that we have to flip this entire reaction. So I'm just going to rewrite it flipped. So it's going to be 6H2O plus 4CO2. Okay, so products become reactants, reactants become products. So now it's going to produce 2C2H6 and 7O2. Now remember, whatever we do to the reaction step, we have to do to the enthalpy. So I flipped it. So before it was an exothermic reaction. Well, if I'm reversing the reaction, it now becomes endothermic. So it is now positive 3,100 kilojoules. Okay, we want to just double check, make sure we're all good here. So we flipped it and made it a product. So let's check that. Okay, so it's in our reaction step, we get 2C2H6. All right, but if we look up here, okay, yes, it's a product, so we're good there. But if you notice in front of our what we want our final step to have, this does not have a coefficient in front of it, but our step does. We need to get rid of this coefficient. All right, so we need to think of what we can multiply 2 by in order to get 1. So we want to multiply it by 1/2. So I'm going to multiply this by 1/2. Okay, so we're going to go through and I'm going to multiply every coefficient because whatever you do to one, you have to do to all of them. All right, so we're going to do 3H2O plus 2CO2. That's going to give us 1C2H6, and that's going to be 7/2, or you can write 3.5, whichever you prefer, oxygen. Okay, whatever we do to our reaction, we have to do to the enthalpy because that's what's going to happen to our enthalpy. Okay, our enthalpy depends on the amount. Well, if we're having the amount, we're going to have the enthalpy. So we're going to have to divide this by 2, or let's just keep it consistent. We're going to multiply this by 1/2. All right, we multiply that by 1/2. We end up getting still positive, okay, because we had it as a positive, 1,550 kilojoules. Okay, so I'm going to just cross this out so I don't accidentally use that. Okay, so right now these are the enthalpies that we have. So I want to go through, before I add these up, I want to make sure my answer is correct. Remember, because there's a lot of other variables here. There's a lot of other molecules that we need to make sure are actually canceling out. So what I would recommend doing is, because this one has so many different steps, okay, I'm going to rewrite the pieces that we actually are new steps that we wrote. So I have this one, and this one. So what I would recommend doing is combining all of your reactants and writing all of your products down of everything that exists, so that way you can organize your information. So what I mean by that is I would go like to reaction A. Okay, reaction A, the reactants are H2 and 1/2 O2. Okay, I'm going to write all my reactants first. So I'm going to go to reaction B now. My reactants of reaction B are going to be C2H4 and 3O2. Okay, I'm going to write the reactants now of reaction C. So I'm writing all reactants down. Okay, and now we're going to go up and we're going to go to, I finished all my reactants, so I'm now going to move on to products. Okay, reaction A, my product was water. Okay, reaction B, my product was 2 waters and 2 carbon dioxides. And then my last reaction, my products were C2H6 and 7/2 O2. Okay, now just a reminder, if something is on the same side, you add it. If they're opposite sides, you subtract them. So let's go through and make sure that our final answer adds up to all these canceling out add up to what we want our final answer to be. So our goal equation. Okay, so I'm going to go through and just see if things cancel out. So I'll switch colors so we can organize that a little bit. All right, so the first thing I have is H2. Nowhere does our hydrogen cancel out, so we are keeping hydrogen. That is one of our products, or one of our reactants. Okay, now I have oxygen. All right, there are quite a few oxygens here, so I need to organize this. So these 2 oxygens are on the same side, so I'm going to add those together. I'm going to keep them into a fraction just to make it easier. So 3 plus 1/2 is going to equal 7/2 of oxygen. Okay, and over here we have 7/2 of oxygen. So these oxygens are going to cancel out because these 2 added create 7/2, and on the product side we also have 7/2 of oxygen. Okay, opposite sides cancel, same sides add. So now I'm going to move on to my next molecule, and I have C2H4. Nowhere in this reaction do I have C2H4, so that's going to stay. Okay, the next thing I have is 3 H2Os. Okay, well, I see other H2Os. All right, these 2 are on the same side, so I'm always going to work on the same side first to make it easier. So these are going to add, and we're going to add them to make 3 waters. So we have 3 waters on this side, and we have 3 waters on that side, which is great because they're going to cancel out, and we don't want water. Okay, and now our next thing I run into is CO2. 2 CO2s, 2 CO2s. All right, opposite sides cancel out. draw my arrow. Okay, we already canceled these waters out. The only thing that's not canceled out is C2H6. Perfect. That is our exact reaction up there. Okay, hydrogen C2H4 is going to create C2H6. So now I know I can add up all of my delta H's. So I'm going to add up negative 286 kilojoules. I'm going to add up negative 1401 and 1550. Okay, and we're going to add all those together, and when you add them, you should get delta H equaling negative 137 kilojoules. All right, and so that's where we would want our final answer. When you're adding, just remember that you look at your place value. So since this one goes to the, this is least specific, and that one goes to the tens place, our answer should go to the tens place. So I am just going to subtract this, and I'm going to make this 140. Okay, and there we go.